So in the previous video we have seen how to resolve this task, minimum window substring, which is a hard one. And I have mentioned that actually we have an option to solve this task using ASCII codes and a little bit to optimize the solution. In general, the algorithm will remain almost the same, but only thing which will change that in that case we will use not maps but arrays, which will store frequency of elements, and the index will be the code of the character. And let's go. So let's see how we can do this in the code. So let's copy this because it's the same. Let's call the method optimized. Okay, now let's create, like in the previous method, two variables for left and right pointers. Okay, now let's create a demand variable. And formed. Now have, like in a previous example, but here I will call it formed. Okay, so the difference between these two, the demands show how much elements, unique elements, and their frequencies do we need to find. Let's say it's like a flag, and formed show how much we already found. And also we will need an array. Let's call it length and left index. We will store the length of our solution and the left index, just in order to use that in order to correct form the substring. I think you will understand it a little bit later. So let's do it like this, -1 and 0. It will be initial values. And now let's create instead maps to arrays, where we will store characters and their frequencies, where index of the bucket will represent the character ASCII code. Well, let's do this. Let's call it character frequency to have. And int character inside window. Why 128? Because as far as I remember, this is distance, let's say, between characters from the start character to the end in ASCII code, which we want to store in our arrays. So for example, for lowercase a, this value can be, let's say, 62. For uppercase a, it could be 92, and so on. And the all characters which we want to store, the last index, let's say, the last code will be 128. I think it will be much clearer for you if you will check the ASCII code table. So now let's move further and let's check if string, actually word1 length is less or equal to word2 length. And if it is, let's return not false, but empty string. Yes, because word 2 represent our target and word 1 where we wanna search. Now let's create a for loop because we want to iterate and to initialize our arrays with required characters and frequencies. So character element word 2 to char array and character frequency to have element plus plus. Okay, and now we will need another for loop where we will iterate through character frequency to have. So int element frequency, character frequency to have, and if element frequency is higher than 0, then we need to increase our demand. So somehow we will find out how many unique elements we need to find, and then we will compare the frequency with the frequency of the current element, and we will know if all conditions match, but we will see it a little bit later. So now let's create a while loop in order to iterate through our string where we find the substring. So right should be less than word1.length. Let's do like this. Now we need to find the current element in our current frequency inside the window. Word1 char at right plus plus. Okay, so we have added the current element and increased the frequency. And now let's check if character frequency to have word1 char at right is greater than 0, which means that the current element is required, and if character frequency window string word1 char at right, and if the frequency match the required frequency to have word1 char at right, then let's increase the formed And like this, we will know if we have found all necessary unique characters and if the frequency match the required frequency. And now let's create a while loop. So how I've already explained in the previous video, when we will find the case when we have in our window all required characters with the required frequency, we need to move the left pointer to the right until the condition will not match anymore, because by doing so we will find the minimum length which actually we wanna know. So let's do this. So we wanna iterate until left is less than right, and formed is equal to demand. Okay. And if length and index is 0, which means that its first iteration is equal to -1, or if it's not first iteration but length and left index is greater than current length, then we need to change the value to better one. Yeah, so length we will change to current one, smaller one, right minus left plus 1, and the index of the left we also will change to the current left index. Yeah, this data we will use in order to call the method substring and to find the substring with the minimum length. Okay. And now let's decrease the character. Let's decrease the frequency of element to which left pointer was pointing. But now, because we move it to the right, we need to decrease his frequency. So let's do this. Word 1 char at left minus. Perfect. And now let's do the last verification. So if character frequency to have word 1 char at left is greater than 0 and character frequency window word 1 char at left is less than character frequency to have word 1 char at left, and then we need to decrease our formed flag. Now we can move the left pointer to the right, and here we can move the right pointer to the right also. And now let's return the answer. So if the length and left index if the length is still equal to -1, which means that it wasn't changed, so we haven't found any match in our substring. So in that case, let's return empty string. But otherwise, we want to return the substring from word1. So let's call substring method, and here we need to call length and left index. So we need to call the left pointer, the index to which left pointer is pointing, and then left index, and then let's increase this one with the length which we have, and by doing so we'll have the second index, and it will help us to form the substring, and it will return the substring with the minimum length which we have found in our word1 string. And now let's call the method. Let's check how does it work. So yeah, it looks to work fine. So now let's analyze our solution. So the time complexity is O(n plus m. We perform one pass to build the frequency array for the target string and another sliding window pass over the main string, but array indexing is faster than HashMap operation because it avoids hashing of overhead. And the space complexity is O(1). We use two fixed size arrays int 128, so the memory usage is considered constant and does not depend on the input size. So let's check what algorithms we have used in the past videos. So we have used, so in the past actually 3 tasks we have used the sliding window technique. So I hope now you know how to use it, and it will not be for you a problem to identify and to implement this technique. So congratulations, and we will see in the next videos. Thanks.